Right now, the Black Widow Pulsar is still spinning 707 times every single second and shredding the star beside it into vapor, and astronomers at Harvard and Caltech have no way to stop it. They don't even fully understand what's powering it. Somewhere inside that spinning corpse of a star is something physics says shouldn't be able to exist. And what they found when they tried to weigh it is the part they still can't explain out loud. It's called a pulsar. A dead star, collapsed down to the size of a city, spinning faster than a kitchen blender. This one lives about 4,000 light-years away in the constellation Sextans, orbited by the burnt-out remains of a companion star it has been slowly cannibalizing for millions of years. That's why they call it a Black Widow. It eats its mate. Every time it spins, it fires a beam of radiation across the galaxy like a lighthouse, and every time that beam sweeps past Earth, we catch a pulse. 707 pulses, every second, without fail, for millions of years. Here's where it gets strange. When astronomers measured the mass packed inside this thing, they got a number that broke their models. Almost 2.5 times the mass of our sun, squeezed into a sphere 12 miles wide. That's not just dense. That's past the theoretical limit for what a neutron star is supposed to be able to hold together. Physicists have a name for the line where neutrons should collapse into something else entirely, the Tolman-Oppenheimer-Volkoff limit. This star is sitting right on top of it, and it hasn't collapsed into a black hole. It's just still spinning, still there, still pulsing right on schedule like nothing is wrong. The obvious explanation was measurement error. Recalculate the mass and the anomaly disappears. That's what teams at Caltech tried first. They couldn't make it disappear. They checked the companion star's orbit, the timing of the pulses, the gravitational math, and the number held. Nearly 2.5 solar masses refusing to become a black hole. The next explanation was that the neutrons inside must be arranged differently than we assumed, packed in a way our nuclear physics doesn't account for. But that raises a much bigger problem. If our models of matter under extreme pressure are wrong here, they might be wrong everywhere. And nobody at Harvard has an answer for that yet. So what's actually inside it? This is the part they're afraid to say out loud. Under crushing gravity that dense, neutrons themselves may not survive intact. Some physicists think the core isn't made of neutrons at all anymore, that at that pressure, matter breaks down one level further into a soup of raw quarks, the particles neutrons are built from in the first place. A state of matter that, as far as we know, hasn't existed anywhere in the universe since roughly a millionth of a second after the Big Bang. If that's true, this pulsar isn't just a dead star. It's a leftover pocket of the early universe, still spinning, still pulsing, sitting quietly 4,000 light-years from your bedroom window. And here's the part that should unsettle you more. We have no instrument on Earth or in orbit that can look inside it and confirm which one it is. We can only measure the outside, the spin, the mass, the light, and guess at the core from a distance, the way you'd guess what's inside a locked safe by weighing it. If quark matter is real, and it's sitting inside an object we can already see with a radio telescope, it means the most extreme physics in the universe isn't hiding in some distant black hole we'll never reach. It's 4,000 light-years away, spinning at 700 pulses a second, and it has been the entire time humans have existed. It means our understanding of what matter even is might be incomplete at the most basic level. And it means every other pulsar in this galaxy, and there are thousands of them, could be hiding the same secret, quietly ticking away in the dark, waiting for someone to ask the right question. So if something that dense can exist without collapsing, without exploding, without breaking apart, what else is out there right now, spinning past us, that we've simply mistaken for ordinary? Tell us what you think is really inside it.